Hi everyone. So for this practice problem, we have another optimization problem. We have a piece of cardboard that is 27 inches by 72 inches, and we're cutting out square pieces from the corners so that we can fold up the corners and create a box with an open lid. Now my red squares should all be the same size, but I could not make that happen, and I'm not going to work at making that happen. Just imagine that they're all the same size. So the red squares are what we're cutting out. They're squares, so I'm just going to call the length and the width of each of these squares x, which means that the base of the box now kind of goes along here because we are folding up the square pieces there, which means that if this full length right here is 27, then this piece inside is going to be 27 minus 2x. Similarly, if this is 72, then this long piece right here inside is 72 minus 2x. And so now I want you to imagine folding up those sides. We'll have the volume of this box, which is length times width times height, will now be 72 minus 2x times 27 minus 2x times the height of the box, which will be x. I want to maximize the volume here. I'm maximizing the volume. So I'm going to have to take the derivative and solve for x. So I think the easiest way to do this would be to multiply all of this out and use the power rule. So if we FOIL all this out, 72 times 27 is 1944. And then I have minus 54x minus 144x plus 4x squared, all of this times x. And so if I distribute that x and combine like terms, I'll have 4x cubed minus 198x squared plus 1944x. So now I'm going to take the derivative of this using the power rule. And I'll have 12x squared minus 396x plus 1944. And I want to set this equal to 0 and solve for x. So I'm going to pull out a factor of 12, and I have x squared minus 33x plus 162. And if we factor this trinomial, we'll get x minus 6 and x minus 27, which means that our possible critical values are x equal to 6 and 27. But I want to go back to the box here, and I want to note that if this full length here is 27, and I'm cutting out two squares of length x, the biggest that x could be is 13.5. And at 13.5, I'm not going to have a box because the width of this box would be 0. So I could have the x could be 0, or the biggest it could be would be 13.5. So this critical value, or this possible critical value of 27, it doesn't fit in the domain. So the only possible critical value is x equals 6. And it doesn't make sense that I'm going to have a volume where x equals 0 or x equals 13.5. So I'm not even going to check these endpoints, and I kept as an open interval because of that. And so the question finally says, enter the area of the square. So if the length of the square is 6, then the area of the square is 36. And do we have a unit? Square inches.